Okay, so hey guys, it's Quincy, and today we're going to continue with our Mergesort algorithm. So let us continue. We already made the things. I just wanted to tell you that we have not put a base case. So I just wanted you to put a base case, the first less than last. Why did we put a base case? Because base cases are important when we have recursive algorithms. A base case is basically going to tell your recursion to stop when it's completed. I mean, or if there is a place where it's completed. Anyway, so a base case is important, so put a base case over there. And whenever you have a recursive algorithm, do have a base case, or else your program is going to fluctuate and burn in hell. Oh, sorry. Anyway, we were over here. We created a new array, which is going to hold the sorted, uh, you know, elements, and you have created ijk because we want the first, mid, and last values to remain constants, and we initialize them for first, mid plus 1 k0. Anyway, so we begin. What you're going to do next, you're going to take the elements of the array and put it in the new array according to which should come first and which should come second. So let's begin. While I is less than equal to mid. Always remember, in this algorithm we're dealing with less than equal to's and not less than. There are no ranges, they're just elements, indexes of elements. So we're going to do equal to. And j is less than equal to last. So while this happens, if, obviously we're going to check between the pointers, right? If to sort array, damn, typing is hard. To sort array of I is less than to sort array of j. What do we do next? Obviously we put I, this to sort array of I, in the position of the new array. So how do we do that? You go new array of k. Now remember, k is the epitome of the new array. It is the pointer to the index of the new array. So we used k in here to sort array of I. Then we have I plus plus and k plus plus. So we go to the next value. Similarly, if this is only going to happen if I is less than j, I mean to sort array of I is less than to sort array of j. But if it's in the opposite sense, you go else, and you do copy, you go paste, and you go over here you have j, and over here you have j. So that's how that works. But just remember that sometimes what will happen is that j will reach last faster than I will reach mid. Obviously that is going to be a case, or either I will reach mid faster than j will reach last. So you have to have a security so that your program doesn't break down after that. So what you do is you go and make another while loop. So you go while I is less than equal to mid again. So if this condition is false, it will go to this one. Okay, you go new. It's actually the same thing, but over here it's actually the same thing. So you don't have to type everything again. This is what's going to happen. Similarly, if this happens, if while again, copy, paste, and it's gonna be the same thing again actually, just that you have to have j over here, and you have to have last over here, and you have to have k over here and j over here, and you have to have j over here. Now why did we do this? Because I will sometimes, because we're doing I plus plus and j plus plus, so sometimes I will reach mid faster than j will reach last, and sometimes j will reach last faster than I will reach mid, because if we're doing a loop, right? So every statement is going to be executed, and out of these only one is going to be executed at one time. So just remember that and do it like that. So instead of you start with mid, obviously because mid will be smaller, go continue with mid. That's all. And also because we have random fillings, we have to fill the whole array. This whole array is supposed to be filled, and if you have some elements remaining, I mean it's not going to make sense about the whole thing. You have to have the filled array, and you have to have it. I mean, there's an option. So then we have what we're going to do is so we have this new array. Okay, good, very good. But this to sort array is not sorted. We need to sort the to sort array, because that's the whole point, to sort the to sort array, because that's the name of it. I mean, it will feel bad if you don't sort it. So we have the new array and we have sorted it in the new, but you have to give this value to this one. Now don't go ahead and do like to sort array equal to new array. That's not going to work because not all the values from here are supposed to be transferred in here. Only a select few. That is, if you have guessed right from the first to the last. Okay, from the first to the last. So you go int, and I'm going to use ing and ing because because I is already declared and j is already declared, and we don't need to use them again. So that's that. So we have j equal to first, and j is equal. I is equal to first, and j is equal to 0. Then we have I should be less than or equal to last, and we have I plus plus and j plus plus. Cool, awesome. Boom. Oh wait, it's not int, it's for. Oh sorry, that was a mistake. I apologize for the inconvenience. Anyway, so beginning with that, we go new. What we're supposed to do? We're supposed to give from the new array to the sort array, to sort array of I should be equal to sort array. Oh sorry, new array, not to sort array. New array of j. Now why is j over here and I over here? Because this array starts from the first. Obviously we have given to sort array because it starts from the first, so this is what the merging is supposed to be done through. Okay, and a new array of j because we put, suppose j is equal to 0 initially, right? Yeah, this is a different kind of for loop because it has commas. Okay, so this is a semicolon and this is a comma, which means these two incrementation things are gonna be executed at one time, and this is the two initialized variables. So this is also possible. You might not have only one statement over here. You might have more than one. You can have infinite number of statements if you have that much time to write so much. But I is less than or equal to last is one condition. You can have multiple conditions with and symbols and or symbols and all that stuff. It's very cool actually, Java. It's even possible in C++ and C also. So if you're wondering about that, yeah, it works. So let us just go ahead and execute this program and see if it works. And yeah, it does work. I think I should just I have some time, so I think I should just go over it one more time. What is this algorithm about? This algorithm is about dividing and conquering, kind of like what Alexander did. I think Alexander, yeah, probably Alexander, and also the British did in India. The British, they did divide and conquer. So how do we divide? We divide it into partitions continuously until we have individual like numbers, and we merge individual numbers together, create clunks of them, and until we sort them together. So this is what happens over here. These are three basic statements: the partition 1, partition 2, and the merge. So we partition, and then merge. Partition, this is a recursive function because this is obviously going to be here. Recursively is partitioning until we have first and mid as not same, because its first is always going to be less than last. So first is never going to be equal to last. Okay, remember that. So we can have at max there will be two numbers, so that's going to be working like that. So then we have partition merge, and then we merge the partitions. What partitions we did over here, we're going to merge them. And you already know what's happening over here, so if you want the code, it's in the description. It's always in the description. And also one more thing, follow me on my Instagram, Twitter, and all those other things. I like being followed, and it encourages me to make more tutorials. In the next tutorial, I'll probably cover radix sort. I'm working on it right now. I'm actually making the algorithm. So yeah, I think it's gonna be fun. So yeah, let's see you in the next episode. Bye bye.